Morning, everyone. Welcome to the CSI webinar around AI-Optimized Architecture. My name's Neil Hart, and I work in the strategy group at CSI. And I will be giving a short introduction, and then I'll be handing over to Chris Parsons at IBM. So at CSI, what we'd like to do is look at having a perpetual edge and helping our clients deal with the challenges and the challengers that they face. And the reason that we've chosen perpetual edge is that while everyone wants a competitive edge, it's no good having it just for today. We need it for tomorrow. We need it ongoing. So an edge perpetually to keep track of competition, challenges and challenges. And the reason that we see that is around three digital forces: acceleration, disruption, and threat. With digital acceleration, of course, everything is getting faster. People have got shorter attention spans. People shopping online, if they don't get an answer straight away, they'll move to another site. And all that acceleration is leading to disruption in the market. Whichever market you operate in, the challenges can come out of unexpected directions. And I think if we look at a few years ago, if Nikon and Canon thought their biggest competitor in the camera market was going to be Nokia or Apple, they wouldn't have believed that. But that's exactly what happened with cameras being involved in mobile phones. And of course, with all that, the digital threat from cyber attacks increasing every single day. And CSI is addressing these digital forces through five broad areas around architecture and cloud, data, which of course is the fuel for cognitive and AI solutions, cyber in terms of protection, especially AI-driven threat protection, and of course applications, which is really the point of all the infrastructure underneath it. But at the same time, where we acknowledge that technology is the means, it's not the end outcome. The outcomes are the end. So if we look at the chap with the space suit there, there's an immense amount of technology built into that suit, but the suit itself wasn't the point. The point was to be able to get a man able to walk in space. So concentrating on the outcomes is very much something that we want to do. And we see four general outcomes that probably every company wants to push: grow the business, save money, innovate, and of course protect. And I don't think these four are mutually exclusive. Probably everybody wants to do an element of all of those. In driving towards those outcomes, CSI follows what we call a 6I process, from identifying the need, imagining a solution, design, integrating into service, and then continually improving those solutions. And what we want to do around AI and cognitive solutions is offer our clients an identify and imagine workshop, which are around those first two steps of the 6I process, to sit down and identify the challenge that needs to be solved and the criteria that the solution needs to meet. And then going into the imagine phase, exploring possible solutions to those identified problems. And those two steps really get to the point, potentially, of a statement of work for implementing a solution. It's not an immediate process, of course. You can't do that all in one day. But what we'd like to offer our clients is free of charge, a half-day workshop to get started with the identify and imagine phases of cognitive solutions. So if you're interested in that, please contact us and we'll arrange those workshops. So why do we think cognitive solutions and AI is getting all the attention it is right now? Because AI is not new. Depending on who you speak to, it have been the foundations of artificial intelligence go back to the 1940s and 1950s. But I think the difference really is around the two creative processes around invention and innovation. So the invention part, creating it for the first time, is very exciting, and that's what gets R&D people excited. But innovation is taking that and using the invention to make a difference, to achieve an outcome. And I think what we're seeing now is AI has been invented, over the years, or from Alan Turing and onwards. And now it's the time to solve those real world problems, innovating fearlessly and putting AI to work. And I think we're seeing a perfect storm at the moment around data and performance. Because if we look at a successful AI solution, it really needs two things: lots and lots of data and really immense compute power. Now, until fairly recently, those were not really freely available. The compute power was very expensive and the data was relatively speaking limited. Today, what we've got is a massive volume of data: digital business, digital transactions, social media, Internet of Things, sensors in cars, most electronic equipment. And of course, now we've got affordable, high performance, GPU-based pay-as-you-go computing, which allow us to take that data, train the models using optimized infrastructure, and then being able to roll the model out and achieve some of those business outcomes. So that's why we were running this series of webinars, because we believe this is the time. It's the age of implementation for cognitive. Get it out of the lab, get it into the real world, and start solving some problems. So with that, I'd like to introduce Chris Parsons from IBM, who's going to take us through some of the issues around the architecture required for AI. Chris, if I could hand over to you.
Thank you, Neil. Yeah, I think I've got control. We'll find out in a couple of seconds. So I'm Chris Parsons. As Neil just said, I'm the AI technology lead for IBM Systems Europe. So that's the team in IBM that are designing and implementing bespoke hardware solutions just for AI. And my role basically is to help you guys, help our clients get the most out of it, help our clients get the most out of this platform, and to do some really awesome things. But I just wanted to start this talk with this chart. Now, these numbers are from McKinsey, the management consultancy firm, and they did some research into the per person percentage increase in labor productivity for these different decades, because they wanted to see how various technologies had impacted people in the workplace, whether it had made us more efficient or how much more efficient it had made us. And one of the things I often hear when I'm talking to people about artificial intelligence is that AI is the next industrial revolution, right? I think that's quite common that people say that. And I found these numbers striking, right? Because I think they show something different. If we look at the 1800s, the advent of the steam engine, which brought about that industrial revolution, it made us per person 0.3% more productive each year. Right? It's 0.3% more productive. Okay, and if we go to IT, so the invention of the internet in the early 2000s and late 90s, that made us 0.6% per person more productive, right? So the internet made us twice as productive as the steam engine ever did. And if we look already in this decade, currently, AI solutions and AI technology is making us 1.2% more productive year on year than we ever have been before. So when people say that AI is the next industrial revolution, I feel like that's an understatement. I think that we can safely say AI is going to dramatically change the way we work, the way our clients engage with us as enterprises, the way people use IT systems, even the way people live is going to fundamentally change as a result of this technology, right? And I think that's awesome because it presents this fantastic opportunity to do things different, to gain that competitive advantage that Neil was talking about, and to iterate on it to do different things. So I think it's very much, we've reached a time now where it's no longer a case of, is AI the answer? But it's how we're going to implement it and how quickly we can transform our business. And I think that is kind of the opportunity. And it's not just me saying that, these are sort of McKinsey's numbers as well. And I feel like this is being represented across many organizations. PwC have a similar study as well. So there's lots of information out there, but I think now is the time to look at change and look at planning for these things. Now, IBM has a rich history of machine learning. This is nothing new for us. I'm sure you guys will be familiar with the chess there, and of course Watson for Jeopardy. But actually, we started building learning computer systems way before that. IBM designed the first learning computer system in 1959 to play checkers. Then we moved on to Deep Blue in the 90s to play chess. Then the increasingly complex Watson for Jeopardy. And obviously this year we announced Project Debater, where we had an AI have a reasoned debate, a research debate with a human debating champion. So I think that really all I wanted to say here is that we've had this rich history of machine learning, right? It's not a new technology. It's suddenly being talked about because suddenly we have enough compute resource and enough data to do something sensible with it, to apply it to our own businesses, to apply it to our own data. But what we've done at IBM is take this 30, 40 years of history in machine learning and make it available to you guys. So we've taken all of that research, all of that knowledge, and tried to create a platform whereby you guys can leverage it to infuse your own applications, to engage with customers in new ways using this technology. And I'll cover more of that in a couple of slides. But I just want to start with what machine learning is. I think often on these webinars, people can just kind of throw these terms around and assume a lot of prior knowledge, and I didn't want to do that. So I've got a quick chart here to go through a few definitions. For me, artificial intelligence is the catch-all term. It's the umbrella term. It's any system that interacts or behaves in the same way a human would. So it mimics human behavior. And it doesn't have to be complicated. It can be really simple, but it just does something a human would do in that similar situation. Now, machine learning is different. Machine learning is about understanding data. It's about taking all of that historic information, all the information you have about your clients, and using that to build a new system that can make smart decisions. And deep learning really is just complicated machine learning, but it lets us do much more complicated things. It lets us build much more intelligent systems. So they're all subsets of each other. So you've got AI, the umbrella term, and then within that, machine learning, which is learning from that historical data. And I want to drill down a little bit into what machine learning is here. So for those of you that have programmed, anybody that's ever written any code, you'll probably know that the first application you typically write is called Hello World, right? Where the task is to program the computer so it just simply prints the word Hello World on the screen, right? The problem is with Hello World is it doesn't really work for machine learning, right? Because if you tell the computer what to say back to you, it's not learned anything at all. That's not machine learning, it's your learning. So how do we do that then? How do we solve that problem? What is the Hello World for machine learning? Well, there is this data set, and I've put a sample of it on this chart. It's called MNIST. MNIST is 65,000 handwritten single-digit numbers. There's only 4 of them on this chart. I had a go at putting all 65,000 in, but there really wasn't room. So I've gone with 4. And the challenge is to build a computer system that recognizes these numbers, okay? Recognizes these handwritten numbers. Now, if I told you that I wanted you to build me this system to recognize numbers, single-digit numbers, and every single number 5 was going to look like the number 5 on this chart, that's really easy, right? Because you just compare the new number to your standard number, and if they're the same, great, right? But the problem is humans. Not every number 5 looks the same. There's variation in them. Not every one looks the same. Everything has that kind of subtle difference in it. So how do we build a computer that does that, right? If we had infinite developers and infinite time, we could probably build a system that could check for every possible eventuality, but most of us don't, right? And this is what's so exciting about machine learning. With machine learning, we can build a system that recognizes these numbers without hand coding it, without programming every possible eventuality into it. All we do is we show the computer that historical data and we let it learn from it. Let it learn what a 1 is. Let it learn what a 5 is, okay? So, and hopefully this won't come as a shock to anybody on the webinar, but computers can't actually see, right? So the computer's representation of the number 1 is this, here on this chart, on the right-hand side of this chart. And I should also say at this point that it doesn't matter whether or not you're looking at handwritten numbers, or whether a client's going to buy Colgate or Aquafresh toothpaste, or even whether or not they're going to want the blue Mercedes or the red one, right? It's all about understanding that data, looking at the underlying information in it. And for this number, the underlying information are these pixel values. So we've got 0 here that represents the white space, all the way up to 1, which is our black ink mark in the middle. So it's just about understanding that information, taking that information and saying to the computer, hey, look at all the 8,000 things, 8,000 examples that I've told you are a number 1, or are a Colgate customer, or are going to buy a blue car, or could afford this mortgage. Look at all of that information we have about them, right? Their name, age, date of birth, where they live, where they work, or in this case, look at the value of those pixels. Look at all of that information and derive from that a pattern. What makes something a number 1, right? What gives something that kind of inherent number 1 property, okay? What makes it number 1? Now, how the computer does that is this. I'm not going to deep dive into this slide, but there is something interesting on here that I want to call out, is that machine learning is basically a bunch of matrix multiplications, okay? It's really simple maths. You just do it lots and lots really, really quickly, okay? And NVIDIA realized that the GPU was an architecture designed to do exactly this type of maths, right? So we've got this workload that is designed, this workload that centers around doing this complex maths, and NVIDIA GPUs that are centered around being able to do that maths really quickly, right? So we thought, why don't we collaborate with them, right? Why don't we open source our processor architecture and start to collaborate with NVIDIA so we can design systems specifically for this workload, right? And that's exactly what we did. So we started to design systems that are completely unique to us, where we have NVIDIA's high-speed communication technology right on our processor, right? So we've baked that right into the chip. And what that means is that we can really accelerate machine learning workloads. We've designed the server for GPUs for machine learning from the ground up. And that really does mean that we can solve problems in 25% of the time. We really can have these colossal speed ups. And when we talk about competitive advantage, being able to do things quickly really matters. Anyway, back to our hello world, back to our example. Once we've done all that matrix maths, the computer has a representation of what each of those numbers are. And they look like this. So on this chart, the blue area, that's where we're expecting to see pen, right? That's where the computer is looking for pen mark. The red area is where it's expecting to see white space, where it's expecting to see the lack of a pen mark. Now, I think this shows something really fascinating, right? If you look at 0 and 1 on this chart, I think, yeah, fair enough. That looks like a 0 and a 1. Well done, computer. You've done a good job of drawing a 1. But if you look at the 4 or the 9 or the 6, or even the 2, right? They look absolutely nothing like the number they're trying to represent, because the computer is not trying to draw an ideal number 1 or an ideal number 2. All the computer is doing is saying, everything you showed me that you told me was a number 1 had this in common, right? And the same for 2 and the same for 3. And that's why machine learning exploded, because you can say, this is what these things have in common. So when a new number comes along, the computer can compare it to these patterns that it's looking for. And if it sees that pattern, then it can make an intelligent decision, make an intelligent product recommendation, handle that case differently. For instance, maybe it's looking at a fraudulent credit card transaction and another card transaction comes in and it looks similar to one that's fraud before, and it can intelligently either block that transaction or route it to a human for analysis. That's really what machine learning is. And that's why we've seen such an explosion in the adoption of it, right? That's why people are trying to use this technology and implement it, because it lets them do the thing they never could before in virtually no time at all, without a colossal amount of development overhead. All you need is enough compute resource and enough data about your client, about the situation you're trying to simulate, and you can build these systems. Right, so I just want to talk a bit about IBM's solutions in this space. So as I said a couple of slides ago, we started to design hardware, design servers specifically around AI, right? We have the 2 largest supercomputers in the world are based on this infrastructure. It's the same infrastructure that we can make available today that you can use to build AI, that we've just used at scale. But also we've got clients that are using one system. We've got clients that are using 11 systems. That's how well this platform scales, all the way up to 4,000 in the Summit system in the US, that biggest supercomputer in the world. It's the same server. They're just clustered together. So as you need to scale, as this becomes core business and you're transforming the way your organization operates, we can scale with you. This is the only platform that can grow to that kind of scale for this workload. So I think this is about kind of planning for where you want to get to. Back to Neil's point about perpetually reinventing and continuing that innovation, right? I think this is key. Is once you've realized, or once you've decided to go on that journey and to make that transformation into the AI space, picking the right infrastructure to grow with that workload, to grow with your business is critical. What this gives you is a unique opportunity to not compromise with your data, right? Instead of looking at tiny subsets of your data or a little bit over here or a little bit there, you can view the whole lot holistically, right? And how much more intelligent is that going to make the AI system? How much more intelligent is that going to make the organization when it's got all that data available to it? It doesn't need to chop it up. It doesn't need to compromise with it. And we can also give you complete control, right? Our systems are open from the ground up. We're talking about open source hardware. We're talking about open source operating systems. And we're even talking about open source frameworks, open source developer frameworks that run on top of that. The likes of Cafe, the likes of TensorFlow, all of these machine learning frameworks that run on top of that platform. So we're open source from the ground up, right? Which again is another unique to this platform. And what that gives you is complete control over how you implement it, how you deploy these things, and where you take it. It's just about providing that accelerated platform. Now, we've actually been able to do some fairly unique things as a result of that, and one of them is this. So for those of you that are already doing machine learning at the moment, I'm sure you will have come across at some point the out-of-memory compute problem. I know it's a snappy name. Basically, this is a challenge where your models are getting more complex, you're starting to use more and more data, and you're running out of space. So this is the current scenario, right? Machine learning needs to go on the GPU. At the moment, we have to fit everything onto GPU memory. We have to put our data on there. We have to put our machine learning model on there. We have to fit our layer outputs on there. It all has to fit in GPU memory, right? Which is a fairly constrained space. It's a tight space. And as we start to work with bigger data sets, right? As we start to work with larger data, as we start to work with more complex models, that space in the GPU memory gets more and more contested, right? So we end up doing this. This is a typical training. So we're training our model. We're computing our tensor. There's our second one. We go to the third layer of the network and we compute our third one. And suddenly we've run out of GPU memory, right? Windows users, this is a blue screen of death. It's just happened on a GPU. And when it happens on a GPU, your machine learning training fails, right? Your job fails. So either you can't teach the computer anymore or you have to scale things back. Right? Mac users, this is the little spinning beach ball you get, right? It's typically not a good scenario to find yourself in, but it's running out of memory. Now, if you think back a few slides, I showed you that chart where we had NVLink, NVIDIA's interconnect technology on our processor. So our processor can literally talk the same language as those GPUs. And what that means we can do is this. So here, unique to power systems, as we're computing each tensor, we can send it to system memory and free up all that GPU memory again, right? So we repeat this process and suddenly we're not having that error we were having before. We can train with larger data sets, with more complex information, right? We can include all that data in there and we can use that to make more intelligent systems. And we've got clients using this. We've got clients using large model support for either really complex problems they're trying to solve or sort of more unique challenges. So we've got a client in the UK, a healthcare company that are using MRIs, right? They're using MRI images of the human brain. And these images are 30 gigabytes each image. So they're hugely complex and they wouldn't fit in GPU memory. So they were scaling things back. They were removing data from the image and using that to train the system. And the problem with that is they're losing information, right? How smart can the system be if it doesn't get to see the whole brain? Right? And using this technology, they can get around that. Using large model support, they can get around that. So that's one way they can get around that problem. As your models get more complicated, as you scale, this technology uniquely lets you solve that problem. Now, we've also built a platform that lets you scale, lets you distribute, right? You can't grow to 4,000 systems without having this platform that lets you scale. And there's a problem with machine learning, and that problem is that when you when you start to train these things, you need to free up those GPUs, right? So imagine here, you'll need to use your imagination. We're training a system to classify different types of dog. And what we need to do is move each photo, here a small photo of a dachshund, over to the GPU, right? And it's taking us a long time to do it. We're waiting for the GPU to be free. Then we're copying the next photo of our sausage dog over. We're waiting again, copying the next one over. And each time we copy an image over, the system has to relearn, right? And it takes a long time. And there we've moved our 7 photos over, and we can say our training's complete, right? And that took a long time. So what we thought we'd do, because we're a clever organization, is we'd buy 2 servers, right? And suddenly everything is faster. Suddenly everything is sped up, right? The problem is it hasn't. And this is why. So even though I've got the same 7 photos of dachshunds, things slow down at this point because the amount of communication I have to do grows, right? Suddenly I have to talk to the other server. Suddenly things have to grow across these 2 systems. Suddenly the amount of complexity has scaled. And what we've done is build a system that takes that away. So we looked at building distributed deep learning. And what distributed deep learning does is it automatically takes your machine learning code. It takes your algorithm that you've already written, and it scales it across multiple nodes, across multiple data centers, across all of these systems automatically, running it in the ideal configuration, right? So it runs your workload in the ideal configuration so that it does scale linearly without you having to rewrite things. And again, this isn't possible without this solution, without having this technology. And to prove to you that it works, what I've done is animate those dogs so they move slightly more quickly. As you can see here, there we go. So I think that is conclusive proof there that distributed deep learning works, and it does what it says it does, right? No? Okay, well, for those of you that are skeptical, these are the numbers, right? So parallel GPUs don't scale linearly, and this is what we were able to do. So the chart on the left there shows ideal scaling and what we can achieve with distributed deep learning, up to 256 GPUs. And actually, it grows beyond that. The reason we stop at 256 GPUs is that when we wrote this research paper, when we published this and made distributed deep learning available to the world, that's how many systems research had in their development lab to test on. So actually, it does continue to grow beyond there. And what that means for you, right? How this translates into business benefit, because that's why we're here. That's what matters. How this translates is being able to take your workload that's taking you 16 days and run that same workload in just under 7 hours, right? Get a speed up of 58 times. Now, let's go back to that competitive scenario, right, that we were talking about earlier on, when it's about differentiating and it's about being competitive. If it's taking your competitor 16 days to derive that same insight, to know those same things about that market, and it's taking you 7 hours, who wins? Right? It's a no-brainer to me. It's obvious to me where we go or which platform makes a difference, right? And it's not just there. We've got speed ups across the board. So I want to talk to you a bit about Snap machine learning. Snap ML, it's been named because it literally does machine learning in the time it takes you to snap your fingers. Right? This is about looking at the common algorithms that are being used today, the common machine learning algorithms that people are using day to day in enterprises now, and giving people benefit from these systems for those algorithms. So this is about accelerating those algorithms. There are 5 or 6 different really common machine learning algorithms. 90% of the machine learning that's out there, if you look at Kaggle data, 90% of the solution uses linear regression, logistic regression, or support vector machines, right? Those are the kind of the big 3. There's 90% of the machine learning out there. And we realized that there was a problem, right? And that's that these algorithms weren't GPU accelerated. And everything that I've been telling you so far is that we've got such a great story around GPUs. Okay, so this is a problem for us, right? Is that all of this great stuff isn't GPU accelerated, and it's what people are using. So how do we do that? So we built SnapML, which literally took these algorithms and accelerated them for GPUs. Okay, now there is a data set out there. It's open source. It was open sourced from a company called Criteo Labs. Now, Criteo are an online web advertising company. So they provide sort of those banner ads that you get on websites, this kind of information. And they open sourced a data set. It's a terabyte in size, and it is click-through data. So it is predictions of what product you will buy based on your behavior before you click an advert, right? So if you work in online advertising, that's hugely important, right? Knowing whether or not people will buy a product before they click an advert means that you can change what adverts you show people. And if you work in the online advertising space, you can see the value in showing people the right adverts, right? So they open sourced this data set to terabyte in size, and there was a world record for solving it. So for building an AI, building a machine learning model that could solve this problem, right? And that record was just over an hour. And it was held by Google Cloud. So they had 90 x86 servers, Intel servers in their cloud, and it took them just over an hour to solve this problem, okay? Now, we took exactly the same code, exactly the same model, but we used SnapML, and we used 4 systems, okay? And that same model trained in just over a minute and a half, right? To actually a greater accuracy. I mean, they're pretty much equivalent, but it's slightly more accurate than the model that was trained in Google's cloud. So we've gone from just over an hour to just over a minute and a half, right? And let's look at the speed of online advertising. Being able to react that quickly to changes in people's buying patterns, in people's behavior because something's happened on the internet, something might have changed, a different product's really popular at that moment. Being able to react in a minute versus being able to react in an hour is the differentiator we're talking about here. That's the advantage we're talking about being able to give to you. And this is about product recommendation. This is about recommending to clients which they should go for, what type of product they should go for. Being able to train that system and retrain it on new data in a minute and a half is a real differentiator because you can get more accurate adverts in front of people much more quickly. Again, with minimal code changes. Oh, and I've not even touched on the data center footprint size, right? Having 4 servers is much easier to manage than having 90. But the point is, it's about that business value. It's about that differentiator, right? It's about being able to do things quickly. And I just want to spend the next 5 minutes talking about that business value, right? How do you identify opportunities for machine learning? Where do you find where to get started with this? Because there's so much you can do, right? You literally can do anything. If you've got enough time and enough data and enough compute resource, you can solve any problem you want. So where do you start, right? And for me, there are 3 sort of places that I think are sort of low-hanging fruit. They're really good places to start looking for opportunities to use this. The first, anywhere where you're collecting data, right? Any of those boring, frankly, web forms we have to fill out, right? We've all been to those websites where you have to enter every single piece of information about your car, what color the wheels are, who was in it last weekend, how many miles it's done, are the seats blue, all this pointless information. And at the end of it, you get a quote for your car insurance, right? Well, what if you didn't have to use a form? There's a startup company that has looked at that. And what they've done is they've built a platform where you walk out to your driveway and you take a photo of your car. That's all you do. And from that photo, it can determine age, make, model, color, likely wear and tear, and it'll give you a quote. Right? It'll give you that quote based on that image data. Now, which is the better user experience, right? Are you going to go to the place where you have to fill out thousands of pages of web forms, or are you going to go and take a picture of your car, right? So this is about understanding the points in your business, your organization, where you're collecting data, where you're trying to attain that data. Maybe it's from staff, maybe it's from clients, and looking at different ways of doing that. Maybe you're using speech. Maybe we're going to use image data, or maybe even we're going to use translation to help us reach new markets, right? So that's the first one. Anywhere you're collecting data, reimagine that. The second are any of those business processes, those mundane business processes, right? These are probably the things that your team say they don't like doing often. Those sort of tasks that take up 80% of their week but aren't why you hired them, those are fantastic opportunities to, improve your relationship with your employees, but also use machine learning. Right? This is about finding out what they don't like doing, because if it's easy, repeated, mundane work, it can be automated. It's an opportunity for machine learning. If you look at the role of field sales, right? Being out there, talking to clients, that's probably what you're passionate about. You want to be out there with people, helping solve your clients' problems, getting them the value they need from whatever it is you're selling. Now, the process is typically that then field seller comes back and spends 80% of their week reporting on the conversations they've had with a client, right? They're filling in all this information, what they mentioned, what they said they were interested in, their likely budget, all of this sort of stuff they fill in, right? And they don't like doing it because what they actually want to be doing is out talking to clients. There's a company that has built an AI-powered CRM, customer relationship management platform, to take all that away, right? It reads their calendar. It understands who they're meeting with and when they're meeting with them and what they're talking about, and automatically fills in all of that CRM data, automatically fills in all of that information so that field seller can get out there and do what they do best and talk to people, right? So this is about looking at those business processes and finding ways to help your employees do them, improving operational efficiency. So the first is anywhere where you're collecting data. The second is anywhere where you can improve your business processes. And the third and final one, and for me this is definitely the most fun, is anywhere where you can preempt your users' next actions, right? This is about knowing what your user or your client is going to want to do next and offering it to them on a plate so they don't have to search for it. So the obvious one for me is when you're booking a flight and then it comes up and says, oh, you're in such and such a place over this week. Say you're in Paris this week. Do you want a hotel? Right? It comes up with that obvious next recommendation. Now, I appreciate that do you want a hotel because you're in a foreign country isn't a massive leap, right? You don't necessarily need AI to do that. But what AI lets us do is replicate that, but in a more way. Google had a problem, and that problem was we weren't sending emails, right? We weren't using Gmail enough. So they looked at why people weren't using Gmail, what was happening. So they did loads of research into it, and it turned out people were replying to emails. They'd write the person's name and then stop sending that email. They'd stop right there. So they'd just write their name and then nothing else. So they got some focus groups in and they started to ask people, hey, why is that? Why are you discarding emails when you've only just written their name? And it turned out people were uncomfortable starting emails. They didn't know how to write that first sentence, that first phrase, right? Typically emails I send begin with the phrase, I hope you are well. And then just below that, I write the email I actually wanted to send, because people are a bit awkward around it. People don't necessarily know exactly the way to start an email. So what they did was try and help people over that, because they wanted people to send email traffic. They wanted people to use their platform, right? So they built an AI that would understand how you speak, understand the kind of phrases, the terminology that you would use, right? And then when you received an email, it would understand any questions in that, understand the likely topics of that email. And then it would suggest to you 3 replies: a positive, a neutral, and a negative reply. So you could just click one of those replies and it would write that for you, and then you could just begin your email from then on. Now, Google had launched this a couple of years ago, and within 18 months, something like 60% of their email traffic began with one of those smart replies, right? So either they'd increased email traffic by 60%, or 60% of what people were doing already, they then had started for them, right? So they realized they were onto a winner. And they've gone a stage further now, where you can just start pressing the tab key and it'll write every word in your email, right? It'll fill the whole thing out for you. I think we're quickly reaching a point where we're just going to have the internet talking to itself, but it's really great, right? Because it enhances your users' experience. It makes them want to keep going back to the platform, because if you do struggle starting emails, where are you going to go? Are you going to go to the place that offers that to you on a plate, or are you going to go to the place that makes you work for it? That means that you have to kind of do all this sort of manual intervention, right? So that's the kind of real advantage that we're talking about here. It's about knowing what people are going to want to do next, finding the information for them and offering it to them so that they don't have to go looking for it. So those are the 3 places for me. 1, anywhere where you're collecting data. 2, any of those sort of business processes that you can improve, any of those challenges. And the third is anywhere where you can preempt what your user wants to do next, offer it to them. These are the 3 obvious places to me to start to use machine learning or start to use AI within your business. I think these are the kind of low-hanging fruit for some really great use cases. Okay, so with that, I'm going to stop and tag Neil back in. I think we've got a couple of minutes left for questions, if there are any. I'm happy to answer them whatever you guys want.
Thanks, Chris. So yeah, absolutely. Open to questions if anyone has any. Nothing coming through. So I think I'd just like to say thank you to Chris. Thanks for everyone who's joined this webinar. And just a reminder about the Identify and Imagine workshops that CSI is offering to identify those business challenges, the outcomes your company wants to achieve. Because I think one of the classic mistakes people can make with a machine learning project is to start with your data, look at it and decide, well, what can we do with the data? Rather, let's look at the problems that are keeping you up at night and then find the data required to solve the problem. So with that, if there's no questions, we're almost at 1:45. I'd like just to thank you again for joining us. Thanks to Chris, and we'll see you for our next webinar very soon. Thank you, everyone. Goodbye.
Thanks. Bye.